It came from the darkness, between the stars. It carried a message, and NASA could not believe what it was seeing. An interstellar comet, a traveler from a distant, unknown solar system, just sprayed an enormous amount of water as it passed by our sun. This is not a drill. This is not a theory. This is a direct observation that has sent a jolt of pure shock and wonder through the astronomical community. It is one of those rare moments in science where we stop, look again, and realize the universe is far more connected than we imagined. The cosmos just sent us a postcard, and it was written in water. For so long, we have gazed out and wondered, are we alone? Are Earth's conditions unique or common? This visitor, 3I Atlas, did not land on Earth, but its brief watery display gave us a priceless sample of another star's domain. The implications are staggering. Let's get formally introduced to our guest. Its name is 3I/Atlas, a cosmic address. The 3I means only the third interstellar object ever confirmed. The first was the strange cigar-shaped Oumuamua. The second, 2I Borisov, much more comet-like. Atlas refers to the survey that first spotted it. The Asteroid Terrestrial Impact Last Alert System in Hawaii. A small dot of light, sliding across the starfields. Astronomers traced a hyperbolic trajectory. A clear sign. Not from here. It swung by the sun, then headed out, never to return. Closer to the sun, it brightened, and a fuzzy coma bloomed. But what shocked everyone was the sheer amount of water, a messenger like no other. To appreciate the surprise of 3I Atlas, we need to understand what a comet is. A dirty snowball. Proposed by astronomer Fred Whipple in 1950. Conglomerations of ice, rock, and dust from a forming solar system. Most of the time, inert and frozen. Time capsules of primordial chemistry. A stellar or planetary nudge sends it sunward. Ice sublimates, solid to gas, releasing dust and gases. Solar pressure and wind forge two tails. Dust and ionized gas, stretching millions of miles. Comet water ice mixes with volatiles, CO, CO2, methane, ammonia. But interstellar space is harsh. Cosmic rays can process surfaces and deplete volatiles. 3I Atlas's vigorous water release implies a remarkably preserved interior. Primordial ice protected over eons. Spewing water means a massive sublimation rate, tons per second. Imagine a fleet of geysers erupting from a mountain of ice and rock. The coma swelled for thousands of miles, a dynamic worldlet awakened. First, the quantity, beyond faint hints, unambiguous and massive. Borisov showed water. Atlas exceeded expectations. This hints at abundant water ice in its parent system. Second, timing. Only recently have we been able to spot these fast, faint visitors. 3 finds already hints they pass more often than we thought. Finally, formation. 3I Atlas composition supports a universal blueprint. Star, disk, snowline. Seeing the same pattern elsewhere is like finding familiar DNA in an alien sample. Not an eyepiece moment. Spectroscopy made this possible. A spectrograph splits light into a spectrum filled with information. Each molecule prints unique lines. A barcode. Water's signature stands out, especially in infrared and ultraviolet. Analyze the coma, match the pattern, confirm the chemistry. Multiple telescopes, ground and space, turn a hint into evidence. Space telescopes bypass Earth's watery air for cleaner readings. Subtract sky background, correct distortion, model the coma. Independent teams verify before announcing 3I Atlas was spewing water. Careful collaborative science. Water in space isn't new. Mars, Saturn's rings, Europa, Enceladus. Our solar system is wet, but that water is local, part of our family. 3I Atlas is different, a clear water sample from another solar system, suggesting water-rich comets may be common across the Milky Way. Our oceans may have been delivered later by asteroids and comets, the late delivery model. If interstellar comets carry water elsewhere, exoplanets could receive oceans too. Comets also carry organic molecules, amino acids found in meteorites and samples, water plus organics, potential galactic seed spreaders. Panspermia remains a hypothesis but grows more plausible. Comparing Atlas to our comets, ice ratios, dust to gas, refines formation theories. Like a botanist getting a seed from another continent, a crucial point of comparison. We have an object from another star, rich in water. Building materials for wet worlds can travel between systems. So, how common is life in the universe? We search exoplanet atmospheres for water vapor signatures. Interstellar deliveries suggest many habitable zone planets may have oceans. Our view shifts, not isolated, a galactic ecosystem. Material is exchanged. Tiny messengers visit us all the time. Abundant mobile water doesn't prove life, but it shifts the odds. Every bright point could be apparent to other water-bearing comets. The chemistry that created us may be at work across the cosmos. 3I Atlas is part of a growing family. 1I Oumuamua, enigmatic, no coma, odd acceleration. 2I Borisov, a familiar, active comet from another star. 3I Atlas, surprisingly high water output. 1 weird rock, 1 normal comet, 1 super wet comet. Diversity is the lesson. With survey power like Vera C. Rubin Observatory, we may find dozens per year, building a true census. We'll classify, study compositions, and map their origins. We are at the dawn of interstellar astronomy. The story doesn't end here. We keep watching as it cools. Changes in activity reveal the structure of its nucleus. Every photon is precious. Years of analysis will follow. Engineers explore rapid response intercept missions. Example, ESA's Comet Interceptor, high-res imaging and direct gas sampling, ground truth from another system. This reminds us why we explore, to meet the unknown and be ready for surprise. A small, icy traveler crossed paths with us and brought a gift, water from another sun. Its visit was fleeting, but its message endures. What will the next interstellar visitor tell us?